right, here is our final lesson in Geometry Concepts for Chapter 4, medians of a triangle. We're going to identify medians, and then we're actually going to find measurements and segments on that median. The median is the segment that goes from the vertex to the midpoint to the opposite side. So we have our triangle, and we're going to connect a vertex to the opposite side. So I know if I hit that midpoint, I have two congruent segments, one on each side of that intersection point. So when I've now taken this opposite side, kind of split it into two parts, they're going to be two congruent points. The centroid is the other new word, and that's where we're going to find the intersection of all three medians of a triangle. So if I were to draw in all three medians, so vertex to opposite side, right? Two segments as being congruent, draw in that third one. This point right here is what we call the centroid. The centroid has some cool characteristics. If we were to cut out a triangle, fold, find the medians of the triangle, and then find the intersection point, find that centroid, we could balance that triangle on a pencil tip or a pencil eraser, which becomes important to know because when we start looking at engineering and designing and building things, there's a lot of practical points of knowing where is the center of a sheet of metal, where's the center at for that gravitation, for supporting all of that weight. We like to know where that center is at. So if we can find the center of that triangle and know where to put a beam or where to put supports at, it's helpful and practical in engineering. So this is why we need to find medians and centroids. All right, so what we know about the intersection of medians of our triangle, that's our theorem 4.9. So the medians of a triangle will intersect at a point that is two-thirds of the distance from each vertex to the median, or to the midpoint, I'm sorry, of the opposite side. Okay? So this centroid is two-thirds of the distance from that vertex to the opposite side. So what that means in terms of symbols, if P is my centroid here, what that means is that AP, from A to that P, is two-thirds of that whole median, is two-thirds of AD. BP, go from B to P, that's two-thirds of the whole median, BF. And CP, if I go from the C vertex to that point P centroid, it's two-thirds of CE, the entire median. And so as you can see, we're obviously going to do some math with that. All right, so we want to draw in our medians. So in triangle ST, draw a median from S to its opposite side. So to find that, the side opposite angle S is TR. So to find the median of TR, we have to find that midpoint. So we're going to measure that, and we can do that with a ruler. So let's see if I can bring up my ruler. And so if I measure that on mine, my diagram is right about 5.8 centimeters. So I have 5.8. And I'm going to have to divide that by 2. And so 5.8 divided by 2 is 2.6. So I'm going to draw my median in to the point 2.6, which is right about there. So I'm going to be able to get rid of my ruler and draw in that median to 2.6. So I'm not sure how to delete my ruler, so we'll just kind of leave it there on the screen. We draw on that segment, so now we labeled this as P, so that means SP is the median of, or is a median of triangle STR. All right, So now how are we going to use these centroids? We're going to take a look at what that helps us find. We know that E is the centroid of triangle ABC, and what they tell us is that DA, so from D to A, this whole length is 27. They want me to find EA in red, and they want me to find DE. I'm going to label that in green. What I started thinking about this as I was getting ready to teach this, guys, is we have to find a way of remembering this. And so I'm thinking of this as triangles, and triangles have a lot of threes. They have 3 sides. They have 3 angles, 3 vertices. What we're going to do then is when we start thinking of this median is always going to divide it into 3 parts. There's going to be a shorter part and a longer part. And so I need to be able to divide 27 by 3, and that gives me 9. So I know that there's 9 in the small part, and then there's going to be twice as many of that. There's going to be 2 of those 3 parts there, and that's 18. So we can go back, we can use our formula that EA, the longer segment, from the vertex to the median is 2/3 DA. So I can do 2/3 times 27, and that equals 18. All right? Or we can just go through and kind of divide that out. 27 divided by 3 is 9. That gives me my smaller segment. And then my larger segment is the 18 that's left over. Because we go through and use that segment addition. That DA, the long segment, is made up of DE plus EA. And so if I substitute in what I know, DA is 27 and EA is 18. We're going to subtract that 18 from each side, and I get 9 is equal to DE. So we have EA is equal to that 18, that 2/3 of 27, and DE has a length of 9. All right, so use your answers to show the following. So ED is 1/3 of AD. So we know 9 is equal to 1/3 times 27. And 1/3 of 27, as we did before, we get 9 equals 9. So instead of doing 2/3 times the larger segment, we can find the small segment by doing 1/3. Because if one part of it is 2/3, the other part has to be 1/3. The other way that they said is AE, that larger segment, 18, is equal to 2 times ED. We said ED was 9, and 18 is equal to 2 times 9. All right, and so that was kind of the mental math that I showed you. The other way is 27 is equal to, the whole segment is equal to the 2 smaller parts. And so 27 does equal 27. So we should be able to do kind of all of these mental math checks to show that our centroid is 2/3 of the distance from the vertex. All right, so let's take a look at what else we're going to do with our centroids. We have P being the centroid of triangle QRS. And we know RP is 10. So we know this larger segment, because we can just kind of tell from judging that our large segment is from R to the centroid, the smaller segment is from the centroid to the side. We want to find the whole segment, RT. So I know that RP is equal to 2/3 times RT. So RP, that's my 10. That's equal to 2/3 times RT. That's our substitution. We can multiply each side by 3/2 by that reciprocal. So if I multiply each side by 3/2, I'm going to do 10 times 3/2. So that's going to give me 15 is equal to RT. So my whole segment has a length of 15. A lot of algebra there. Let me talk you through what I would do there. I know that RT is 10. I know that this is twice as large as that. That's kind of what we did with 2/3 and 1/3. So 10, if I divide that in half, I get 5. So that means the smaller segment is 5. So now I've got 10 and 5 labeling both parts of that interior segment. Now I can go back and reread the question and say, okay, what do they want me to find? They want me to find RT. RT is that long segment from vertex to side, they want me to find the median, and so I can add those two segments together. So let's take a look at a couple of checkpoints here. Find BE and ED. So we know that BD, the whole segment, is 24. If I have the whole segment, that means I need to divide it into the two smaller parts. Remember, think of threes, so divide by 3. So BE, so the segment chunks are going to be 8. My small chunk is going to be 8. My larger chunk, my larger segment needs to be twice that, so we get 16. So you do have to come down and label your answers for me. BE is equal to 16. ED is equal to 8. And I can double check with some mental math. 16 plus 8 does equal 24. All right, let's take a look at what we have here. Now they're telling me IJ is equal to 4. So IJ, that's my smaller segment. It's going from centroid to side. I know that my larger interior segment is going to be double that, so this is going to be 8. So I've labeled everything. I know I found the two parts of the interior segment. So I'm going to go back and see what they want me to find. They want me to find IG and JG. So IG is the entire median, so I add those together and get 12. JG, we already labeled, and we get 8. All right, let's take a look at our last one. They want me to find ON and NL. OL is 20, and that's my larger segment from vertex to centroid. I know that half of that, 20 divided by 2, gives me my smaller segment. So I'm going to have 10 there. Now I have both the interior segments, so I'm going to go back to what they want me to find. ON was the first one they had listed, so O to N, that's the centroid to midpoint, centroid to side, and we labeled that with a 10. I then have to find NL. NL is the entire median, and so I add those two segments together and get 30. Okay, so we're looking to try and find interior segments around that centroid, guys, whenever we can, and then using our addition to go through there. So we'll do some practice of this with our warm-up tomorrow, but make sure you come with any questions. Have a good evening.